Hi, my name is Brian Caffo, and welcome to this week's Ask Brian, part of our weekly newsletter. Our weekly newsletter is called Monday Morning Data Science. This is one of its features. We also post articles. Roger posts podcasts. So sign up. There's a link in the video description below. Okay, so I got a question, and I get this question a lot, so I'm going to answer it. I've kind of answered it before, but I'm going to answer it again. And usually it revolves around machine learning, but now I've got the same thing with artificial intelligence. So the question is, will artificial intelligence eat statistics? I think meaning will take over statistics, generally speaking. So this is my um, artificial intelligence robot there, and this is my statistics taco. And the question is, will the artificial intelligence robot eat the statistics taco? Stay tuned and you'll find out. Okay, so first of all, we should discuss a little bit about what all the hype about artificial intelligence, like where is it coming from? And the answer to me, it seems like, is very real, legitimate successes in a couple of domains where they didn't think these successes would come at this rate. So in perception, things like image classification and segmentation and things like that, and language processing are examples where artificial intelligence, in particular deep learning, has just made fantastic inroads and put the field forward in ways that people didn't think would happen for another decade or so, or multiple decades. And so there's a lot of enthusiasm regarding that, and it's really exciting to see. I must also add, but the question is then, at what point will classical statistics become kind of useless if this trend continues? So thinking short term, maybe next 10, 15 years, 20 years, let's think in that regard, because 50 years, who knows what's going on? Or maybe I'll talk a minute at the end about that. Um, some uh, core components of classical statistics that I think are essential and might help us frame this discussion. One of the core components is formally connecting your data to a population. So you might do that with something like your sampling scheme. You might do random sampling, for example, or you might do it with some amount of formal modeling and say that my model and my likelihood or whatever is the mechanism by which I'm going to connect my data to the population that I'm interested in. Or part of the sampling scheme you might think of, generally speaking, as the study design, that you design the study in a way that you can connect your data to your population effectively. So these are the sorts of things, and many others related to this are the sorts of things that statisticians think about when they talk about generalizability. Another big aspect of statistics is quantifying uncertainty, such things as error rates. And I think in AI research and in machine learning research, statisticians have a lot to contribute just on these topics alone. So insofar as, let's suppose AI and machine learning take over everything, statisticians would still have a lot to contribute about these topics in specific. But one area where I think classical statistics kind of still has a bit of a monopoly, and it doesn't appear to be going away anytime soon, is this idea of parsimony. And parsimony is the idea of creating the simplest possible explanation and maybe no simpler. And to me, parsimonious knowledge that gets created is the best knowledge, because that means we've taken something complicated and we've reduced it to something simple that people can understand better. So as an example, if you fit a linear regression, and yes, maybe you miss some variation, but the linear regression describes the trend of what's going on well, then you've created some amount of parsimonious knowledge, and you have a rough idea of where you'll be, a year from now, let's say, by looking at the slope of the line. And you can get predictions like that with artificial intelligence. In fact, I tried this experiment and it worked, where you try to generate data, say, from a line and try and predict the line using artificial intelligence. In fact, linear regression is a special case of deep learning with no hidden layers and a um, uh, identity activation function. So you can have it as a special case, but what you'll find is that the algorithm, correctly avoids the overfitting, tries the various aspects of a complex model, and boils it down to something reasonable. The process takes a long time, but I think you would certainly say you don't see the line and you don't see the model fit. It certainly isn't instantaneous, and it seems like kind of a poor use of artificial intelligence. And yes, it develops the reasonable predictions in that case. However, it doesn't give you kind of a reasonable model that you can then just look at and say, yeah, this is a line. As opposed to going the opposite direction of postulating maybe this is a line and directly fitting a line to it. So I think this idea of parsimonious statistical models will keep going forward for a while. I'd say in my day-to-day life, there are problems that can get recast very neatly as an artificial intelligence or machine learning problems, such as image segmentation. And then there are other problems where creating a parsimonious understanding is exactly what we hope to accomplish, and in which case some of these other techniques aren't quite as useful. And so I don't see those kinds of problems, especially in the realm of science, going away anytime soon. I would say just this thing I alluded to earlier, the idea of maybe AI not eliminating the need for statistics, but potentially eliminating the need for statisticians, in the sense that we could, given lots and lots of data sets and analyses that statisticians produced, use AI to try to produce the similar analyses. In other words, mirror what the statistician is doing. I've seen some research on that and people trying to do that. I don't think the realization of that appears to be anytime soon, but that again wouldn't eliminate the need for it to get rid of the need for statistics. It would get rid of potentially the need for trained statisticians. But I certainly haven't seen any great successes in that realm, or any real hints of real success. But nonetheless, it's an interesting area of research that is ongoing right now. Okay, well, keep those questions coming, and I'll have another video for everyone next week.